I'm here to talk about the best practices for fair workflows on Dockstore. Specifically, what is fair? And more importantly, why should we be striving to achieve those principles? How does Dockstore deliver on these principles? And how do we leverage Dockstore's features in order to create a fair workflow? I'm sure most of us have already heard FAIR before, but just as a quick review, it's an acronym standing for Findable, Accessible, Interoperable, and Reusable. It was originally coined in a 2016 paper that was specifically referring to scientific data. However, in the time since, it's expanded to other protocols, including computational workflows, which is what we'll be focusing on today. Now, workflows ultimately are a little bit like a piece of data in the sense that it is a scientific object to be managed. It's also a representation of the methods you use to reach some sort of goal, usually some sort of data. So it's important to keep track of them in a good way. Specifically, why do we care is not only does it just make things easier to cite and easier to get recognition for your work, it also becomes easier to reproduce your results, not just for other people to reproduce your results, but for you to reproduce your own, because you can help keep track of what version of a pipeline did I run my data on. These fair practices, in fact, tend to be good software development practices in general, which is always a good thing to practice. And the collaborative nature of open source software can really benefit the bioinformatics field. So how do I do it? I'll be talking about a couple of general ideas as to how Dockstore is leading into these principles, as well as specific pieces of advice. One of the first things that we do recommend is hosting on Dockstore, of course, because Dockstore is designed from the ground up to be a one-stop shop for bioinformatics workflows, in the same sense that bioRxiv is the one-stop shop for biopapers. Once the workflow is actually on Dockstore, it benefits from our faceted search feature, which will harvest metadata from descriptor files. But you can also add your own UI configurable labels, which will show up on a Dockstore entry, a little bit like hashtags in a tweet. Dockstore integrates with ORCID, so your work can be shared on your ORCID profile very easily. We also have an organizations and collections feature. This is an example of a collection that is part of the BioData Catalyst organization. So this is a collection of several UWGAC related workflows, and people who are members of the Dockstore BioData Catalyst organization can add to this collection, adding any arbitrary number of workflows. On the left here. And on the right, they can also add a description to provide context for what that collection actually represents. It's a little bit analogous to playlists and channels on YouTube, except the playlist, so to speak, has some text indicating what brings it all together. Now, how do you actually get things on Dockstore? There's a couple of ways to register, but the way that we recommend is the Dockstore GitHub app. In this scenario, your workflow is partially hosted on GitHub, but it is mirrored on Dockstore, and that mirror is kept up to date using the Dockstore GitHub app, which works in tandem with a small configuration file. So for example, we have a configuration file on the left, which results in the entry on the right here. So this primary descriptor path, goLeftFunctions.whittle, actually exists in a GitHub entry and is mirrored on Dockstore. There's also a parameter file, which you can't see in the screenshot, but if you were to go to this page, you would see it under this section. So the reason why we recommend this method is not only are you benefiting from Dockstore being a collection of bioinformatics workflows and is therefore easier to find your workflow than if it were only on GitHub, once it's actually set up, any updates you make on GitHub will automatically show up on Dockstore. So if you push a new commit to GitHub, that will be updated on Dockstore, usually in less than 5 minutes, depending on the GitHub API. This currently supports pretty much every language that Dockstore supports, with one asterisk that we do support CWL workflows, but technically this doesn't support CWL tools. However, if you want to register a CWL tool using this method right now, you have the option of using our CWL wrapper to turn that tool into a workflow. Or you can wait for our next release, which is coming up pretty soon, and that does support CWL tools. In addition, this method can handle multiple workflows in a single repository, which is a pretty common practice. You would just simply add a few more lines here. So however you like to organize your repositories, Dockstore can handle it. You can optionally define which branches to include. By default, every branch will be included, but if you have a GATK-sized repo, or if you have a lot of testing branches, you might want people to not accidentally use older branches or branches that might have breaking changes. So you can set up your dockstore.yaml file to only show a handful of those. We have more information about this on the Dockstore blog. Regarding accessibility, Dockstore by design is an open access repository. You can view all the workflows you would like without needing to log in. We also support versioning with software. This usually can be building upon the source control repository, but it doesn't have to be. You can also host directly on Dockstore. More on that in a moment. Dockstore also integrates with Zenodo to build immutable digital objects, which is great for citations. We also have integrated support for parameter files, which tend to look a little bit like this. You can enter them directly onto, if you're running a workflow on the command line locally, you can enter a parameter file directly, so you don't have to retype in everything. And this actually leads into one of our most common recommendations, which is to provide test data. These files work best if you actually have them pointing to real data. Now, when I am saying real data, I don't necessarily mean controlled access top med data. It could be downsampled 1,000 genome files that you're hosting on your GitHub repository. Alternatively, you can also be looking at cloud resources that are already out there and are already open access. Having test data for your workflow is a great way to make it more accessible, because it provides not just a, here's an example of how to run it. If it is a working example, then it increases confidence that the user is setting it up correctly and that your workflow is functional. Speaking of which, regarding citability, Dockstore integrates with both Zenodo and ORCID. So if you have a particular version of the workflow that you're very happy with, you can mint a Zenodo object, which will essentially make an immutable version of your workflow. It'll create a little button right here. And if you choose to link your Dockstore profile with your ORCID profile, you don't have to, but it is an option. You can also have this show up on your ORCID profile along with your publications, of course, making this more accessible. Interoperability is a word that we say a lot here at BioData Catalyst. We can leverage the GA4GH standards for sharing workflows with our compute partners, but our users usually don't see that directly. So I'm going to be focusing a little bit more on things such as README files and checker workflows. So with Dockstore specifically, if there's a workflow that has a checker available for it, there's a button that will appear in the UI of the original entry that'll take you to the checker entry and vice versa. If you're not familiar with checker workflows, it's essentially a wrapper around your original workflow. So let's say that you have a known input and you know that it should always result in a certain output. A checker workflow will put in that input and make sure that the output matches what you expect. Now, this could be anything from, does it have the expected MD5 sum, or it can be a detailed line-by-line comparison of a truth file, the one that you're hoping to match, versus a test file, which is the output you got when running this particular workflow. The actual nature of how you do this will depend on how you write that validation tool in your checker workflow. These are good for building confidence in your workflow. By definition, you have to include some sort of functional example test data. So this already builds off the confidence I mentioned, including test data in the test parameter file, excuse me. And if this passes, that indicates to the user that their particular setup on their particular backend is functional. So this is good not just for users, but for developers as well. In fact, I use checker workflows so much while developing. I made a template repo, which is hosted on the Dockstore GitHub organization, to have several working examples of different types of checker workflows, and also has some importable checker validation tasks, which you can put into your own workflows if you would like. But people are not really going to get to the checker workflow or even your original workflow if they don't know what it does. So we do recommend including a good and detailed README. What does the workflow do? What do the outputs scientifically represent? And how is it used? It's important to make note of any assumptions. For example, if your workflow only works on autosomes, make note of that. If it expects a specific file format in its name, make sure to mention that as well. Try to include any cloud resources. If you know that your workflow will not work if it's given less than 32 gigabytes of memory, then make sure to make note of that in the workflow. And depending on the workflow language, you might even be able to hard code it into the workflow as well. If at all possible, try to include some estimates of cloud costs. Now, scaling can be pretty difficult to estimate sometimes, but if you know that if we run this on, let's say, this 1,000 sample cohort on these resources using Google preemptible instances, which are significantly cheaper than non-preemptible instances, that it costs $2. Having that information on your README can be really helpful to people just trying to scope things out. It'll increase confidence. And of course, it can be helpful for people who are writing budget proposals. We've all been there. Pretty much everything I've been talking about up to this point all leads back into reusability. So I'm going to be focusing sort of on like one of the more big picture parts of reusability, which is versioning. But I do also want to mention that we do have a best practices for secure and fair workflows resource on our documentation that I recommend that you check out if you want some more information. It has some more specific points similar to what some of the ones I've been talking about, and a couple that didn't make it into this presentation. What I recommend doing is that when you make an important change to the main branch, consider making a release which can serve as a snapshot of your repository. This is one of those things that is just sort of generally good software practice anyway, but it is worth mentioning. One of the reasons why we recommend this, besides it being just good practice, is that Dockstore will hold on to your releases and branches. And again, assuming that this was registered using the Dockstore GitHub app, these new releases will show up almost immediately on Dockstore. You don't need to go into Dockstore and synchronize it manually. So for example, here, this version 1.0.0 actually corresponds to this release here, which is for the checker workflow templates that I was mentioning earlier. The 0.100 is the second one over here. Now, these are good if your users want the latest and greatest, but can also be useful if you accidentally make a breaking change to something. Again, we've all been there. Users can then fall back on an earlier version. Now, I do want to note that technically, this type of versioning is not immutable in the same sense that the Zenodo digital objects are, but it is still a very good step that you can take. Now, what we were previously talking about was more focused around developers, but as a user, you can still help with the FAIR principles by citing workflows that you are using by their version number. And also consider sticking to one specific tagged version throughout your analysis. You could always pull in a certain tool on the main branch and use that for your analysis. But if you do that, there could be a change to that branch. And the next thing you know, half of your samples were done with one version of SAM tools and another with another. And this can easily be prevented by sticking to a specific version for some consistency. As a side note, this goes for Docker images as well. We recommend using a specific digester or tag instead of the latest. Of course, there might be certain reasons why people would prefer latest, so this isn't a hard and fast rule, just a general recommendation. And just sort of summarizing those recommendations, which again, we have all this and more in our documentation. Register on Dockstore using the Dockstore GitHub app. Consider making uses of releases and versioning. Provide test data, usually in some sort of JSON or YAML format. And if at all possible, point to some existing resources that a user can put in there and actually run their pipeline on. Leverage checker workflows to further increase users' confidence. Include a thorough README. What does this do? Why do we have it? What do these inputs represent? What do the outputs represent? It's all good information to have. And if you're going to be publishing your workflow in some sort of scientific paper or something of the sort, consider minting a citable data object using Zenodo and sharing that on your ORCID profile, both of which integrate directly in with Dockstore. Just wanted to bring an example of some fair work on Dockstore. The Broad Institute's Viral Genomics collection and the Nextflow Core organization both have some great examples for you to look at. I want to give a shout out to the Dockstore team for helping me work through this presentation, Avni for giving me some more information on Zenodo, and Dennis Ewan at OICR because I may have borrowed a couple of images from his older presentations for this one. So thank you to everyone at the Dockstore team and to everyone else for listening.